A kernel is the central part of an operating system. It manages the tasks of the computer and the hardware, most notably memory and CPU time. The kernel can be split into two types of modes: kernel mode, which is referred to as 0, and user mode, referred to as 1 in the operating system. The kernel mode contains privileged instructions, since it has the ability to alter operating system properties, like resources such as memory or video cards, and input and output. The kernel system code directly accesses hardware and memory in the system, while the user mode runs user applications. Today, we'll be taking a deeper look into what a microkernel is. A microkernel is a piece of software or even code that contains near minimum functions required to implement an operating system. A microkernel can be broken into separate processes, known as servers. Some of these processes, like device drivers, run on user mode, while others, such as CPU scheduling, run on kernel mode. Each of these separate servers run in distinct address spaces. Since the servers are in such close proximity to each other, there exists a strong protection between them. And the operating system protection-oriented system provides a means to distinguish between authorized and unauthorized usage. Now that we know how a microkernel is originated, let's find out how it works. Applications such as YouTube, for example, may request a microkernel to allow speakers to play audio from the video. The microkernel in turn will direct the request to the device manager for access to the speakers. The application has to make a call to the microkernel, also called message passing, in order to contact device manager for access to the speakers. The microkernel will then direct the request from the application to the device manager. From this, two steps have already been executed. The application requesting for speakers directed the call to the microkernel, which also directed the call to the device manager. The device manager will direct the request sent from the microkernel and the application used before to request speaker access. Another three steps are executed when the speaker returns back to the device manager with the access, then to the microkernel, and finally back to YouTube that had requested the service in the first place. 6 steps in total were executed through message passing, which created overhead due to the amount of message passing.
Let's talk about the two types of kernels, monolithic and microkernel. Monolithic kernel is a single large process running entirely in a single address space. All kernel services exist and execute in the kernel address space. Microkernels, on the other hand, implement user and kernel services in different address spaces. The execution of a monolithic kernel is faster since the communication used between application and hardware are system calls. However, monolithic kernels take up a lot of memory and are difficult to maintain since there is a large amount of source code. This was the rising problem that gave birth to the microkernel. The main idea was to reduce the source code and allow easy management by separating services into user and kernel mode, while simultaneously increasing security and stability. Since user and kernel services are kept in separate address spaces in the microkernel, if any user or kernel service were to fail, it would not impact the rest of the operating system. In conclusion, a microkernel is like a safe family sedan, and a monolithic kernel is like a sports car. One of the first microkernels was developed in the 1980s at Carnegie Mellon University, called Mac. This eventually led to Darwin being created, also known as Mac OS, which was a loosely based microkernel approach. The microkernel also influenced Windows NT, which was based on a layered microkernel. Unfortunately, it performed worse than Windows 95. Now, let's talk about the advantages of the microkernel. Easy, it's relatively easy to extend the microkernel. Faster development, quickens the development process since the software can be tested without requiring to reboot the kernel. Maintenance, simple and easy to maintain. Robust, in theory, microkernel is more robust than a monolithic structure. Upgradability, it is easier to migrate the operating system to a newer architecture. Now let's discuss the disadvantages. Degrade in performance, potentially at risk of performance loss. Hard to manage. Process management can be very complicated. Longer process time. Processes take more time than monolithic structure, as discussed previously. More requirements. Microkernel requires heavy resources. And tough to debug. Debugging can be extremely cumbersome. I hope you now have a better understanding of how microkernels work.